All right, so before getting into why people use R, why? Why are we asking this? Nobody's going to ask, well, why do people use Ruby? Well, even if Ruby's not your thing, you could understand, why some people might like it, or, why Perl? Well, you may not like Perl, but you can see what would attract some people to it. For R, I think it's a little more subtle question. Okay, so what is R? Well, it's an open source statistical language, and it's become a de facto standard in statistical research. Now, I want to emphasize research. A lot of people who are doing traditional statistics are not using R. If people are doing things that are well-established, well-known, sort of routine statistics, a lot of these people prefer SAS, because if there's a SAS proc, do what you want to do, why not use it? But the people who are writing new statistical code, they're doing research, they're publishing papers, they're doing something a little bit off the beaten path, these folks are predominantly using R. If you're going to publish a journal article, people assume if you're going to slice in some code, it's going to be R. Or if it's not R, you have to justify it. So, little history. The name R doesn't really suggest what it's about. S does. So S for statistics. S was the original language developed in Bell Labs in '76, and then went through a major revision in 1988. The version of R that we have now is a lot like S from '88. Officially, R says that it grew out of Scheme. I think you have to look kind of hard to find the family resemblance to Scheme, but it's in there somewhere. Superficially, I think it maybe resembles Fortran more. And as Dennis Ritchie said about C, he said it's quirky, flawed, and an enormous success. I would say R is even more quirky and more flawed, but maybe not as successful as C. That's weird. Okay. So, an example of the popularity of R, these were the languages used in a data analysis competition from Kaggle.com. As you can see, the bar on the left, the majority of the users of the contest participants used R, and they said that among the winners in the contest, even a larger percentage used R. Now, here's a similar graph for bioinformatics, but let me explain first. Bioinformatics is a different animal. The word bioinformatics means different things to different people. You can go to a bioinformatics conference and have some people who are essentially computer scientists, but they have some interest in biological problems. You have people who are essentially biologists who do a little bit of number crunching, and you have people who are statisticians who do some analysis on biological data. So you can have people with almost disjoint interests who are all calling themselves bioinformatics. So within that community, this is the results of a user survey. More users said they were using R than anything else. And I would imagine the second place and third place, Perl and Python, these are probably the people who are more on the computer science end of bioinformatics rather than more on the statistical end of bioinformatics. A lot of the early gene sequencing software is written in Perl, for example. Okay, so what's it like to use R? Well, it's a lot like smoking. This is a quote I ran across recently that said, in the beginning it's difficult and one may get headaches and even gag the first few times, but in the long run it becomes pleasurable or even addictive. Yet deep down, for those willing to be honest, there's something not fully healthy in it. So what is the syntax of R like? There's a new machine learning book that just came out from O'Reilly by Drew Conway and John Miles White. And they say R has a unique and somewhat prickly syntax and tends to have a steeper learning curve than other languages. And there's a popular guide to R called the R Inferno. The opening part of the book says, if you find yourself in R hell, this is your guide. So what about speed? R is not known for its speed. In my experience, it's about 100 times slower than C++. Of course, that varies tremendously. Yesterday, Jeff and Stefan showed some slides, some benchmarks where maybe it was 1,000 times slower than C. Sometimes it's within an order of magnitude of C. It may even be close to parity depending on what you're doing. If you're doing some large calculation where you're just calling a R veneer over an enormous amount of computation in C, that's going to be fairly efficient. But 100x is probably a good rule of thumb. And so what about tool support? Well, R has not quite caught up with Visual Studio 95 as far as tool support. There are some efforts to improve this. There are people who are working on, like Revolution Analytics is working on a graphical debugger for R, but to my knowledge, nobody's produced anything yet that was as convenient as, say, writing C++ with Visual Studio in the first edition. So with these drawbacks, why do statisticians like R? And this is a question I pondered for a long time. I wonder, what is it about this language that people like? There's poor tool support, it's slow, it's quirky. Why do people like it? And here's a partial answer from someone from Google. The best thing about R is that it was written by statisticians. The worst thing about R is also that it was written by statisticians. The people who've developed R understand what statisticians want, and they don't want what computer scientists think they want. So R is really a domain-specific language, and I think the key to understanding R is that to understand a DSL, you have to start with the D, not the L. So imagine you were trying to learn SQL by reading the SQL language standard. So, okay, this is a programming language. What kind of types does it support? What are its control structures? How do you modularize it and so forth? And you'd be asking the entirely wrong questions. I mean, you could start reading the spec cover to cover, and maybe on page 400 you get to the select statements. Select doesn't sound too important, and keep going. You could totally miss the point of what the language is about. Or PowerShell. In some way, R is kind of like PowerShell. Whenever somebody will ask, why is PowerShell this quirky language? Like during Bruce Piet's talk, someone said, didn't we learn 30 years ago this isn't this is a bad idea? And his response was, it's a shell, it's a shell, it's a shell, it's a shell. Because PowerShell is a shell, different rules apply. Things that might be a bad idea in general, are different at the command line. Well, the same thing for R. As a statistical language, some things that would be bad in practice in general, people love. So, to the statistical community, the alternative isn't, say, Python or C++ or C# or something. The alternative is SAS. They're going to use a statistical DSL. And people love their DSL. And they will try to use it where it is completely inappropriate. If at all possible, they will stick to their mother tongue. And that's understandable, but it also causes a lot of headaches. So to the point of R being a DSL, I first tried to learn it as a programming language. So it's a language. So I've learned Perl before. I've learned C++. I've learned whatever. So you get a book on it. You start. What are the data types? What are the control structures? And that is absolutely not the way to understand R. If you approach it that way, it won't make any sense. So you really have to get into the mindset of the person who's using it, the person for whom it was designed. So statisticians have different priorities from software developers. Even when they're writing software, they're not thinking like software developers. So if you could stick a statistician and a programmer in a functional MRI and you're watching their brains as they're writing code, there's different areas that are going to light up. They're really not thinking about these things the same way. And maybe a more subtle point, statisticians have different priorities than mathematicians, which is something else that took me a while to wrap my head around. That you might think, well, statistics is just a specialization of math, but there's a big cultural divide. There are a lot of differences between statisticians and mathematicians, and it shows up in the software that they use. I mean, my initial training was as a mathematician. I did research in PDEs and started out that way. Then after that, I left academia, worked as a programmer for a while, and statistics is really my third career. So, I mean, I've had the perspective of a software developer, of a mathematician, and a statistician, and they really do look at the world different ways. Mathematica is very popular in math departments. And so when I started working in statistics, I just assumed people there would like Mathematica too, and it's almost unheard of. Because statisticians' needs are very different than mathematicians in subtle ways. A lot of people learn R at the same time that they learn statistics. And so they don't even really think of R as a programming language. It's more like this is just how you do these different things. This is how you do a t-test. This is how you do a linear regression. And they may never study the language as a computer language. So for example, when I first looked at the R language specification, it had all these to-do comments in it. I thought, oh my gosh, this language has been out for years and there's to-do comments in the language spec? Well, it was a low priority. That didn't stop anybody from using the language. What would stop them from using the language is not having the functionality they need to get their work done. So you tell them, look, here's this beautiful programming language. It's documented and it's well-tested and like that. Like, yeah, but can I get my work done in it? I think this is also sort of like PowerShell or any other shell in that a lot of people use a shell without ever really studying it as a language. I doubt many Bash users could tell you, questions about the grammar of Bash as a language. They just think, well, this is just how you do things. You type ls and you get a list of files. I think a lot of people see R the same way. That's just how you do statistics with this package. So one way I think about it is it's almost like R has a language rather than R is a language. Sort of like the shell has a language rather than really thinking of it as being a language. Okay, so why would statistics need its own domain-specific language? What's unique about statistics? I mean, why do you have? I mean, do you have a DSL for everything? DSLs for historians or English teachers, or why is it different? Well, one point that's fairly obvious is that you want statistical functionality to be handy. You don't want a lot of ceremony associated with doing common tasks. To a statistician, typing math.log to take a logarithm would be as awkward as in a typical programming language having to say flow control.for or branch.if. it's like, why am I doing this? This is common as dirt. It should be easy to do. Same thing with having graphics capability as part of the language. If you have to pound include something or set a reference to do graphing, that would feel as foreign to a statistician as having if statements in one package, but having to include something else to use a while loop. When a statistician's working with data, they're working with tables, or most often a table. Not really joining things together, but they have tabular data, and they're working with this, and they need to make very quick, on-the-fly kinds of queries and filtering as they go. They can't write something like a SQL select from where statement. They want to do something in 2 keystrokes to find out, are the values positive or whatever. Because data's tabular, statisticians often think in terms of columns, very often in terms of columns, and that's why vector operations are so important. So in R, you only have vectors. There are no scalar types. Everything is a vector, for better or for worse. So if you want a scalar, you have a vector of length 1. This is maybe a subtle but important difference. It's missing data. Missing data is just a fact of life. Data sets are often not complete, and R handles that well. So in newer versions of C# you have nullable types. Well, R has nothing but nullable types. You always assume that data can be missing. And in fact, R has 2 kinds of null. So you could have NA, which is the most common for missing, but you could also have null, which is sort of different, like pretend this wasn't here. It's kind of mysterious. But because missing data is a fundamental assumption, different routines have different ways of dealing with it. But it's the assumption that you're always going to have missing data. So if you're, say, passing an R vector into C++, you're rewriting part of your code to make it faster, you can't assume that a vector of doubles contains doubles, because it contains doubles or NAs. You always have to keep that in mind. And another thing that's desirable in the statistical language is patterns. Sort of like regular expressions or patterns for text munging. R has some pattern descriptions for common statistical tasks. So some advantages of R. As the Python people say, it comes batteries included. Everything that people typically need comes in one download, in one namespace. You could use R for a few weeks before you discover that you want anything else. Contrast that with something like Python. I used Python for a while before I heard of SciPy. And I used SciPy for a while before I heard of Matplotlib and IPython. So it's not this one package unless someone happens to tell you these are the 4 things that you really need to create a scientific computing environment with Python. And that sort of multi-part nature is a barrier to adoption for statisticians. What most people do with data analysis is interactive, and so R is optimized for that. R makes interactive data exploration very easy, at the expense of safety or efficiency and some other things. But it does make exploring a data set very easy. You just download some data, start playing with it right away. So I've never programmed in SAS, but from what I understand, it's about as sophisticated as writing DOS batch files. So that if you're going to be doing statistical programming, it's easier in R. Of course, R is open source, which is a bigger deal in academia than it might seem. Even wealthy institutions like my own, where you could buy whatever you want, you have to go through the effort of buying it, and that can be huge. So if you can bypass the bureaucracy and download a tool, you're a lot more likely to use it. In my institution, at first, a lot of people were using S+. It was a commercial version of the S language. And even though they had the commercial version on their desktop licensed, most have switched over to R. I'll give some examples in a minute of this succinct notation I keep mentioning. So, for example, so if you have some missing data, you want to figure out which elements are missing. Well, you can do that briefly. You have this, when you have a Boolean expression, or a Boolean expression inside a vector, it means apply this operation to the elements that satisfy that. So in this case, for those elements of X where the index of X is contains a null value, set it equal to 10. This looks a little weird because you have X on the outside and inside, but you could have something different inside. Do something for those elements of X whose corresponding element in Y satisfies some condition. Now, this is maybe this is probably a better example of where R really shines. I'm going to show you the code to satisfy this in one line. So you're trying to fit a linear model to some data with 3 inputs. You want to include terms for a constant, for an intercept term. You want to include X, Y, and Z individually. You also want to include pairs, like an interaction for X, Y, and one for Y, Z, but you don't want X, Z. This is a fairly complicated problem, and there's the solution in one line of R. R has this regular expression-like syntax for linear models. So when this says X plus Y plus Z squared, that does not at all mean that you add these elements and square them. It means include those terms in your model that are represented by this symbolic sum. And the minus X colon Z means except for that one. So, if you're doing this all day, and a lot of statisticians do, you can do this very briefly in R. Okay. Here's another regression example that I pulled out of some book where it's looking at caterpillar growth as a function of the tannins in their diet. So in R, you could just simply say read a table, suck in this data file. So when you say attach data, that's saying sort of bring this file's headings into my namespace. So if I say names, it tells me here are the column names. And then I say fit a linear model for growth as a function of tannins. And that's it. It does a simple linear regression, and if you type summary, it will show you all the gory details of what it's concluded from linear regression. Recycling is another feature of R that is not all that important, but I bring it up because it illustrates how R is finely tuned for the needs of its users, even doing things that might be bizarre to other users. So if you have vectors of 2 different lengths and you add them, that is okay. It recycles the elements of the shorter vector to have enough elements to add to the longer one. When I first saw this, I thought, oh my gosh, I can't believe this. This should be an error. But no, it's something that statisticians need to do, and they make it convenient. So, for example, if I have a vector of elements 1, 2, 3, 4, 5, 6, and I want to add to it a vector of length 2, that's fine. It simply repeats those 2 elements, 10, 100, 10, 100, 10, 100, and adds them to my original vector. And this is something statisticians do. Now, here's a stranger example along the same lines. Suppose I create a matrix out of those elements, a 3 by 2 matrix, You can see here the subscripts start with 1, because this is a part of the Fortran legacy, and also stored in column major form. So the 1, 2, 3 goes across the bottom instead of the top. Now, if I add the vector 10, 100 to this matrix, you might think it would add 10 to the left column and 100 to the right. But no, to R, that matrix is really a long string of numbers stored by columns, and so it adds the shorter vector to that by columns. So it starts at the top, works its way down the columns, alternately adding 10 and 100. Okay, so some lessons from R. Users may have very different priorities than the computer scientists or vendors creating tools for them. Users will put up with a lot of crap to get their work done. By contrast, if you give somebody a tool that does 99.9% of what they need to do, but it doesn't provide that last 0.1%, and they don't know how to provide that 0.1% themselves, it's no go. But you give them a buggy, poorly documented program that crashes routinely, but it lets them get their work done, they will love it. You will have to pry it out of their cold, dead fingers. I'm not saying R crashes routinely. There are other statistical tools, though, that do crash routinely, and people love them because they can get their work done. Yeah, I mean, it seems so funny to me to hear somebody say, yeah, it's a great program. Hey, it crashes, but it's great. I mean, not crashing is not a high priority on their list. Getting their work done is a high priority. And then the downside of people loving their tools is they will use them where inappropriate. R is designed for interactive data exploration, but it's increasingly being used for more procedural kind of programming, systems kind of programming where it's not appropriate, it's not efficient. Okay, so a few resources for R. You can find the R project, R-project. You can download R, download the modules, etc. I've written a brief introduction summarizing some of the things I found most surprising learning R coming from a programmer's perspective. Most books on R are written for statisticians. It's the line, here's a task and here's how to do it. The only book I've seen that's geared more toward programmers is The Art of R Programming. So it approaches R sort of like a programming language. It was written by a computer scientist who got into R for his research. And there's a Twitter feed, RLang tip, that gives one tip about R each day. I started this account and then I handed it over to Dave Smith from Revolution Analytics, and it's done better in other hands. So that's a way to get a little dose of R every day. All right, so do I have some time for questions? How are we doing on time?
We're doing great on time. We have 10 minutes or a little more.
Excellent. All right, so questions?
So not so deep linguistically, but when you're splatting or distributing the short vector over some matrix,
yeah, can
you quickly give a really high-level scenario of like when and what you really do? Like, what's a real data example of that?
Yeah, why would you want to do that? Well, so in the matrix example, well, I guess that doesn't work. So maybe you have some periodicity to your data. You're collecting something, a set of values on each user. And like for each subject in a trial, you measure 3 things. And you really want to manipulate that data in triples. So you want to add something to everybody's first value, something else to the second value, something to the third. Now, that will not produce an error in R, but if the shorter vector's length is not a divisor of the longer vector's length. It's still legal, but you'll get a warning. So if you want to add a vector of length 3 to a vector of length 7, that will be a warning. If you want to add a vector of length 3 to a vector of length 30, that's okay.
Yeah. That was, oh, there.
How does it relate to APL? It looks a bit APL-ish. Is there any?
I can't comment on that because I don't know APL.
But
I do know you don't need a special keyboard to write R, but
traditionally that was used by statisticians.
Well, no, I think it's sort of in the spirit of APL, though, in making some operations very succinct. Yeah.
You said that ease of installation was really important, but then you also said that even people who had S Plus already installed migrated to R. Why is that?
A lot of packages would come out for R first, so it was easier to get new software that way. And a lot of people who could afford S Plus had collaborators who could not, and so R became sort of a lingua franca that way. And there's a couple of questions up here. Yeah, well, just a second.
So, what do you think a language could do to target that demographic of statisticians and other people who need to do statistics even better than R?
Right. I guess you have to pick your battles. For something like Julia, I would target the people who are doing simulations and research, not the people who are doing marketing reports and, so you want to compete with R, you don't want to compete with SAS. And you want to make common tasks easy to do. And so you have to kind of see, what is it that people do all day? Well, they run t-test and regression. That fits a lot of folks. In fact, in the cross-validated Q&A site, somebody has kind of a to-do list that said, I would use Julia if it does these things. So you might want to take a look at that. So there's a.
I think question. I know that guy. So
yeah, there's a question behind you. Yeah.
Hi. Yeah, it's a related question. Really, it's like, I mean, you've said a lot about why people do use R. I mean, are there reasons why they don't, and what are the kind of main complaints about R from those who do use it?
It's slow. It uses memory inefficiently, and there's no small change to R that could make it more efficient. Now, I don't know that firsthand, but from a colleague who's a compiler guy, he was saying, R spends most of its time looking up symbols and managing memory. And if you made the actual number crunching instantaneous, it would still run very slow. It doesn't have these safety mechanisms that a systems language would have. Most people would like to get an error if they try to add vectors of different lengths. That's just an example of the kind of thing where R is not designed to protect you from mistakes. It's designed to make it easy to explore a data set. Yeah.
Does SAS store larger databases?
Okay, the question, does SAS store larger databases than R? I think so, because I haven't used SAS, but I know people who work with enormous data sets in SAS, and I don't know of anybody who works with enormous data sets in R, because you run out of memory. I've done a lot of work taking code that was written in R and rewriting it in C++ for efficiency. And sometimes the efficiency, or the runtime, I should say, of the R code is infinite because it'll run out of memory.
So often with these sort of highly compact scripting languages for specialist domains, they have this sort of unfortunate property that after you've written the code and you leave it a little while, you can't understand your own code, let alone somebody else's. Right. So in your experience, does R suffer from that a bit?
I'd say R programmers suffer from that. I don't think it's intrinsic to the language. Like the language has this feature where you can insert a pound sign and put comments after it, but this is not a widely known feature. Yeah.
Okay. Any more? All right. Thank you very much.
Thank you.